So the next topic we're going to be covering is the Pythagorean Theorem. So let's look at our TEKS. 8.7c, I can use the Pythagorean Theorem and its converse to solve problems. 8.6c, I can use models and diagrams to explain the Pythagorean Theorem. 8.7d, I can determine the distance between 2 points on a coordinate plane using the Pythagorean Theorem. So in order to use the Pythagorean Theorem, we need a specific kind of triangle. We specifically need a right triangle, which is symbolized using this right angle symbol right here. So we have legs, which are the two sides touching the right angle known as A and B. So this shape right here is my right angle A, and B consists of the sides. The hypotenuse is the side opposite of the right angle known as C. So what we're going to do is every time we have a right angle, we're going to draw an arrow going across it, and that's always going to be C, the hypotenuse. The hypotenuse is always going to be the longest of the three sides. So the formula, we actually don't even need to remember it for the Pythagorean Theorem. It is under additional information. We have it right here, a squared plus b squared equals c squared. So in any right triangle, the sum of the squares of the shorter sides, which is in this case going to be a and b, will equal the square of the longest side c. In other words, a squared plus b squared equals c squared, or the area of the square created by side A plus the area of the square created by side B is equal to the area of the square created by side C, which we're going to see in the diagram like this. So for example, when the area of the two squares are given in the model, what is the side length of the third square? So here is our right angle. So I know that this is these two that create the right angle are going to be A and B. And then I have my right angle right here. If I draw an arrow across it, this is going to be C. Now it doesn't tell us these side measurements A, B, or C. Instead it tells us the area, which means that 16 is equal to B squared. So B squared equals 16, because this is the area of the square. So B squared gives me the area of this square right here. Right here we have 25c squared is equal to 25, because the area of this square is 25. And so we're looking for this area right here. Now according to the Pythagorean Theorem, a squared, or the area of this square, plus the area of this square should equal the area of c squared, which is the largest square. So I have a squared plus b squared equals c squared. Now I still don't know what a squared is, so I'm going to leave it a squared plus, I do know what b squared is. B squared is equal to 16 equals, and I do know what c squared is. It equals to 25. So something plus 16 equals 25. Well, in order to figure out what that something is, we can work backwards. Minus 16 from both sides. A squared equals 9. So the area, or a squared, is equal to 9. 9, there we go. But now we don't want to figure out what the area is, we want to know what just that side length is. So we're going to do the opposite of squaring a number. We're going to take the square root. The square root of a squared cancels out, so I'm left with a is equal to, and then we'll take the square root of our number. Remember, Control x squared, this button right here is going to pull up our square root symbol, and then the square root of 9, I end up with 3. So that side length, the third side length that we're missing from the square, is equal to 3. Let's go ahead and look at the next one. The converse states that if a squared plus b squared equals c squared, then the triangle is a right triangle. So let's look at the first one. So we have 3 lengths, and I need to know, can these lengths make a right triangle? Plug it into the Pythagorean Theorem and see if it's true. So just like it said up here, the hypotenuse is always going to be the longest of the 3 sides. 16, 30, 34. 34 is the longest, so 34 is going to be C. A and B don't matter which one's which, but if you always want to make A the smaller one, you can. So a squared plus b squared equals c squared. Instead of a, I can plug in 16. 16 squared plus, instead of b, I can plug in 30 squared equals, and instead of c, I'm going to plug in 34 squared. And then we can type this into our calculator. 16 squared plus 30 squared equals 34 squared. And then we'll go ahead and type that in. This says true. So I know that this is a true statement. These are equal to each other. So this is a right triangle. Example number 2, can the lengths 12, 12, and 24 make a right angle? Plug it in. So we're going to make this one again. A, B, and 24 has to be C because it's the longest side. C is always going to be the longest side. So again, A squared plus B squared equals C squared. Instead of A, I'm going to plug in 12. So 12 squared plus 12 squared equals 24 squared. And then we'll type that into our calculator and see if it's true or false. 12 squared plus 12 squared equals 24 squared. And we get false. So this one does not make a right triangle. And then let's do our last one, a coordinate plane. So the right triangle, the Pythagorean theorem can be used to find the distance between points on a graph. We're going to create a right triangle where the diagonal is C. So we're trying to figure out how far away is this point from this point right here. So let's go ahead and draw a line to connect them. This is going to be our hypotenuse, and then we're going to go and make a right triangle following the grid lines. So here's our right angle. This one across from the right angle is going to be C. Then we have A and B. So then we're going to, in order to find the distance, A squared plus B squared equals C squared. And then for A, we're going to count 1, 2, 3, 4, 5, 6, 7 units for A. So A is equal to 7. And then for B, it's 1, 2, 3, 4, 5, 6 units for B. So instead of A squared, I'm going to plug in 7 squared plus, and instead of B squared, I'm going to plug in, this should be 6. There we go. B equals 6. I'm going to plug in 6 squared equals C squared. So we can actually plug this into our calculator. 7 squared plus 6 squared equals C squared. So I'm going to plug in the whole thing. But in order for this to work, we need to actually put n solve in front of it. So we're going to go to the front, menu 3-1, plug that into our equation. I'm looking for C, so we're going to put comma C, and C is equal to 9.21954. We're going to round to the hundredths place. That's 2 decimal places, so 9.22. So this is how far away this point right here, point A, is located from point B. It's 9.22 units away.